Hello everyone, I am Jaganmohan, working as assistant professor in Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. Today I will discuss about computer organization subject. We'll discuss introduction of computer organization and architecture and introduction to Boolean architectures also. What is the computer organization and architecture? The definition is the computer organization architecture is the study of structure. It is the study of structure. What is the computer behind? What is the performance is going on inside? What is the instruction will be done? That will be analyzed the computer architecture and design and operation of the computer system. It explain how computer components organized and how they work together process data efficiently. The inside computer system, they'll do many operations in the computer system. Like we know that all the registers and we are having computer memory and CPU and central processing unit in the behind computer system. It will do operations. We are using system means inside operations. Many operations will be done, like registers to register operations will be done. Most of the instructions will be executed. Most of the instructions will be executed means we are operating system. We are executing some data also. We are getting output also. And the key points is describe the internal structure of the computer. In this computer organization architectures, it will discuss about explain mostly interaction between hardware components and help improve system performance and efficiency. Forms the foundation of computer design and development. Entire computer organization architecture, it will shows in the subject shows about what is the CPU inside communications will be done, like what is the instructions will be executed, what will do the CPU, what will do the memory, what will do the input output operations, will be seen in the we'll see in the this computer organization architecture. What is computer organization? The definition is computer organizations refers to the hardware components are connected, coordinated to perform operations. Computer organization is nothing but inside CPU. Most of the devices are connected like parallel and series. Register to register is connected parallel or series also. And why it is connected means it will perform the operations. Like what operations means, if it is we are giving the data, whatever we are giving the inside. Output devices like a keyboard and mouse, input devices, keyboard and mouse, we are giving the data like by our human language data. It will be processed through binary data, and the operations will be done in the CPU. Like the operations will done means inside CPU, the memory device and the CPU signals, control signals and bus system will proper communication will be done. Like each unit will be the communication will be executed. After executed, we are getting the data. The instruction will be performed in the inside CPU, and we are getting the output. Whatever we are giving the input, that will be generated through CPU. CPU analyze the operation, and we are getting the output inside. The output devices, we know that like printer and mouse, printer and desktop. And the examples is memory organizations like bus systems. Bus systems is nothing but bus system. It will do the one place to another place. Data will be processed through the bus system. And the control unit operations. Control unit, it will generate the control signals, like which operation need to be executed first, which operation to execute a second operation. Like if it is we are doing multitasking through the in the system, CPU analyze the what will be the first executed operation, what will be the next second operation. CPU analyze the operations, and CPU generates, control unit generates control signals, and it will execute the data. and a data flow between components. Data inside the CPU, data flows each and every part, like system to registers to registers, or registers to bus system, registers to memory, registers to control unit. It will generate data, will be flow all the units after the all units, it will be executed, and we are getting the data. Suppose what instruction, it will be called instruction is nothing but whatever we are giving the data, that will be human language to machine language converted. After conversion, it will be executed means we are getting out data in output devices. Output device is nothing but like monitor. This is called one instruction. Computer architecture definition. Computer architecture refers the logical design. It refers logical design, like gates. It will be gates, and gate, or gate not gates. It will be refer as a design and functionality of computer system seen by the programmer. Key points is defines capabilities of computer, specifies instruction sets and addressing mode. It specifies instruction sets. Instruction sets means nothing but if one instruction executed means one of the task executed. It will be number of instruction sets will be there, and addressing modes, whatever executed data, that will be stored in the memory. Determine system performance and functionality, acts as a bridge between hardware and software. Computer architecture act as a bridge between hardware components and software components. It will executes, it will passes the data through bus, and it will generate output. And examples is instruction set architecture, it is called the ISA, and processor design, and word length, and register structure. A difference between computer organization and architecture. We will see computer organization is deals with implementation. It deals with implementation is nothing but whatever we are giving the data, that will be executed now. It will be proper way. It will implement the data will be implemented. And the computer is architecture is deals with the design. It only deals with the design. Focuses on hardware operations. It will focus us on hardware operations. It will focus us on system functionality. Hardware operations is nothing but in hardware we are having motherboard. In motherboard we are having registers and flip flops will be there. Flip flops will be store one byte of data. Registers contain most of the registers are having 8-bit register, starting onwards 8-bit, and high memory 64 GB registers. In registers to register instructions will be executed, these are called hardware operations. Focuses on system functionality means is nothing but whatever the operations is done, we are getting output in the system functionality. And explain how tasks are performed. It explains how tasks are performed, and it explains what tasks can be performed, what are the pending tasks we need to perform. The system software analyze, these are pending tasks, the system software communicate with the hardware, and all the operations will be performed. And includes buses and control signals relationship, include instruction sets and registers. The architecture defines what the computer does, and organization defines how computer does it. And importance of computer organization and architecture benefits. Improves computer performance, and enables efficient hardware utilization, and supports software execution, enhances system reliability, and helps in designing advanced computer systems. The next topic is Boolean algebra and logic gates. It is an introduction to Boolean algebra. The definition is Boolean algebra is a mathematical system. It will completely mathematical calculations will be there, and used to represent, analyze logical operations in digital systems. Whatever we are giving the data inside the CPU, whatever human language is converted to zeros and ones, it is called binary operations. It is having particular design. whatever the operations we are giving, like logical operations we are having now, like mathematical plus addition, addition operation, multiplication, division, it will be converted as a zeros ones code. It having particular diagrams, particular architectures, particular representations will be there. And key features is uses two values only, zeros and ones. Any architecture will take, any logic diagram will take, the code will be, the truth table will be zeros and ones only, like nothing here, not we are not taking like twos, threes, like that. Only zeros ones code will be there, like it is called binary data. Zeros zeros represents false or off. Zeros represent, it is a negative value, it is a like a false or off. One represents true or on. Once represented true value and or on. It will be used in logic diagrams and registers also. Binary information will be there now. Whatever we are giving the human data, that will be converted through zeros ones code. It will be represented as a diagrams like logical operations. It will forms the foundation of digital electronics and computer system. The mainly digital electronics used in the computer organization architectures. The importance is used to designing digital circuits. Used to design digital circuits is nothing but whatever we are having zeros ones code will be there, that will be converted at digital circuits. So in motherboard we can see small circuits will be there in hardware, that will be called digital circuits. These digital circuits is passes the memory one place to another place. Each fraction of seconds, source to destination will be process the data, helps the computer process information and simplifies logical expression. Through these logic gates, through these digital circuits, the logical expressions will be simplified. Binary values and Boolean algebra. Binary number systems. Digital device operate using two states. State is off state, one of the on state. Binary value is, if it is off means it will be taking as a 0, and it is on state means it will be taking as a 1. False also, it is taking as 0. True means it will taking as a 1. And the examples is light off means 0, light on means 1, switch off means 0, switch on means 1. And Boolean variables and expressions. Boolean variables, a Boolean variable is nothing but can have two values, zeros and ones, 0 and 1. Boolean expressions is logical relationship between variables are represented using Boolean expressions. Example, logical operations means it is a addition and multiplication and division. These are called the logical operations. Examples is a plus b. A plus b is nothing but a is the one variable, b is the one variable. Here addition operation will be doing a dot b. A dot b is nothing but a multiplication b. Here doing operation is multiplication operation. And a negation, like a we can call a bar, a or a complement. Complement is nothing but if it is opposite of a. If it is having, we are having a value is 0 means we'll take a complement as a 1. Purpose, these Boolean expressions describe the operation of digital circuits. The basic Boolean operations is AND operation, OR operation, NOT operation, and significance. AND operation is it will produces output 1 only. AND operations means nothing but it is a multiplication operation, we can say, like 1 into 1 means 1, produces one output 1 only when all inputs are 1. Like if we are having a value and b value, both are 1, and c value is 1 into 1 means 1. If it is AND operation, 1 into a value should be 1 and b value should be 1, then only we get c value 1. This is called AND operation. And OR operation is it produces output 1 when at least one input is 1, and our operation is the A value, B value, minimum should be 1, like A value 1 or B value 0, C value will be 1, like B value 0, A value 0, B value 1, again also will get 1. One value should be, one positive value should be there. And not operation is like A values is 0, 1, A value should be 0, 0, like 1, 1. A complement is, or A negation is, we are getting 1, 1, 0, 0. The inverse, we can call inverse also, like if it is A value 0 means it will be converted as a 1, like A value 1 means it will be converted as A complement converted as a 0. The opposite will be done. Significance, these operations are building blocks in the digital logic systems. And the AND definition is an AND gate performs logical AND operations, and the characteristics is output is high only when all inputs are high. Outputs is high means highest value. Here highest value is 1, 0, 1. Highest value means 1. A or B values are 1 means we are getting highest value 1. Output is high only when all inputs are high. If any input is low, the output becomes low. If it is any output low means if it is A value 1 and B value 0, A value 1, B value 0, the AND operation A dot B, this the result will become 0. At least one highest A and B variable should be 1 into 1. All positive values will be there in the A and B. So this is called, if any input is low, the output becomes low. The Boolean expression is y is equals to A into B. Application scenes, security systems, industrial automation, decision making circuits. We are in AND gate used these security systems, industrial auto domain, and decision making circuits. And OR gate is, an OR gate performs the logical OR operations, and characteristics is output is high when at least one input is high. Output is low only when all inputs are low. We can see here A and B, 1, 0, C. Like 1, 0 means we are getting 1. Like all inputs are 0, 0 means here we are getting 0 only. The one element should be highest value. Highest value is nothing but 1. Total A and B two variables, minimum one element should be highest value. If it is all are two low values means we are getting lowest value only, that is 0. If the Boolean expression is y is equals to A plus B, the OR gate will be used in alarm systems, communication systems, and control circuits. And a NOT gate is, the NOT gate perform inversion. Characteristics is converts 1 into 0, converts 0 into 1. Operations with single input. NOT gate will be only one variable should be there, and 0, 1. A inverse means 0 means we are getting 1, 1 means we are getting 0. The Boolean expression is y is equals to A bar. The NOT gate applications is signal inversion, digital processing systems, control applications. The applications of Boolean algebra and logic gates. The major applications is computers and laptops and mobile phones and digital clocks and calculators and traffic signal control systems and security and alarm systems and communications networks. These applications is these are the applications of Boolean algebra. Boolean algebra we can use widely in mobile phones and digital clocks and calculators also. Thank you very much.